Alright, last two examples in section 3.2. Here we go. We're going to prove the identity that the tangent of theta over 2 is equal to sine of theta over 1 plus cosine theta. So this is not our official half-angle identity for tangent. We're actually going to use that to help us do this problem. So instead of doing the more complicated right-hand side, let's go ahead and start with the left-hand side. The tangent of theta over 2. We're going to replace that with our identity that we learned today. I'm going to go back and look at it really fast. So 1 minus cosine theta over 1 plus cosine theta. So square root of 1 minus cosine theta over 1 plus cosine theta. That is just our half-angle identity. I really want that to look a little neater. A lag on my computer messed that up for me. So try one more time here. 1 minus cosine theta divided by 1 plus cosine . Okay, so let's go ahead and rationalize this, shall we? So to rationalize it, I'm going to multiply both the numerator and the denominator by 1 plus cosine theta. Okay, so when I multiply that, I get a difference of squares in the numerator. Let me go down here. So 1 times 1 is 1. Because I don't need a big square this time. So 1 times 1 is 1. And then negative cosine theta times 1 and positive cosine theta times 1 cancels out those terms. Negative cosine theta times positive cosine theta is negative cosine squared theta. And then in the denominator, since we multiplied the radical times itself, square a square root, and it gets rid of the radical. So we have 1 plus cosine in the denominator. Okay, so numerator, maybe you've noticed that this would be a Pythagorean identity. So we can replace our 1 minus cosine squared in our square root with a sine squared in the square root. And if we square root something that's been squared, it gets rid of the square and we're left with neither a square nor a square root. So that gives us sine theta divided by 1 plus cosine, oh, I don't know where that squared came from. Probably just because the one up on the top has square, so I was thinking that one did too, but it doesn't because in this case the radicals cancel each other out because what we multiplied by was exactly the same, so that part's not squared. Okay, sorry about that mistake. So that is the right-hand side, and we're done. Let's look at example 9. Let's use what we've learned in chapter 3, both sections, 3.1 and 3.2, to do this one. So cosine 3 theta, we don't have a formula for cosine 3 theta, that's what we're going to try to find here. So to do that, we can get 3 theta by taking 2 theta plus theta and using a sum identity. So using a sum identity, that would give us the cosine of 2 theta times the cosine of theta minus the sine of 2 theta times the sine of theta. Now let's replace our 2 thetas with formulas that we learned today. Now if we want everything in terms of cosine, then the formula we want to use for cosine 2 theta is the one that just has cosine in it. So we're going to replace that with 2 cosine squared theta, which is one of our 3 double angle identities for cosine. And then we're going to replace our sine 2 theta with the only thing we know for that one, which is 2 sine theta cosine theta. Now don't forget that's just for this piece, and so we still have this additional sine theta that will be extra multiplied to that. That'll be important here in a second. Now let's go ahead and distribute things. So this one can distribute through these, and we can combine those together so that they're just in sine squared instead. So that gives us, I'm going to stay with the blue, I like it, 2 cosine cubed theta minus cosine theta minus 2 sine squared theta cosine theta. We might feel like we've come to the end of this problem, but not really, because we are trying to just get this in terms of cosine. We have this sine getting in the way of that. But fortunately, the sine squared can be replaced by 1 minus cosine squared. So let's go ahead and simplify this now, so that we have 2 times 1 minus cosine squared times cosine theta. So that gives us 2 minus 2 distributing, oops, I need to distribute both the 2 and the cosine theta. This is a little complicated. So I have 2 times 1 times cosine theta, which is going to be 2 cosine theta. And then we'll have, oh, it's negative as well, right? Then we'll have negative 2 times negative cosine squared times cosine. So that's going to turn that into a positive 2, because there's negative times a negative. And then we have a cosine squared and a cosine, so that's a cosine cubed. And we're going to combine that onto what we already have. So we already have this 2 cosine cubed theta minus cosine theta. So now putting those together, we end up with 4 cosine cubed theta, because I added this term and that term together, and then minus 3 cosine theta, because I combined those 2 terms together, here and here. And this is our new identity for cosine 3 theta. How many different identities are possible? Many, many possibilities. Fortunately, we don't have to memorize or find them all.